All right, today we are beginning at chapter 3. We're in the very first section, exponential functions, so get excited for that. And this is going to lead us into logarithms, of course, so let's get into it. First off, since we're doing exponential functions, clearly we're going to practice exponents. 3 to the 4th, my friends, is not 12. 3 times 3 times 3 times 3. You can type that in your calculator if you really had to. 3 times 3 times 3 times 3, 81. Okay, when we were multiplying exponential expressions, you're going to add your exponents, so 2 plus 5. Now, we can never leave our final answers with a negative exponent in it. So remember when you have a fraction bar, if you were in the numerator, you can switch it to the denominator, and that will change the sign on your power. I have no problems with x squared. That's a positive 2. I'm going to put a 1 to hold the place, and I'm going to combine x cubed, x squared, and make it x to the 5th. All right, D, very similar. Negative exponent in the denominator, so I'm going to move to the numerator. So 5's 5. 5's not offensive, we'll leave it, but I'm going to move x to the positive 6 up there with it. And I'm just not putting the 1 in the denominator because it's unnecessary, of course, to hold the place. All right, what are we going to learn, friends? How to recognize and evaluate exponential functions. You're going to need your graph calculators for that. How to graph exponential functions, and then how to solve some real life problems. So exponents, of course, grow very quickly, so that is why you most definitely want to have your calculator with you. Exponential function with base a is denoted by f of x equals a raised to the x. Notice it says a is greater than 0 and it can't equal 1. Clearly, if you have 1 for a, 1 to any power is going to just continue to equal 1. It really kicks it into what we call a constant function. Equals the same thing. So first thing we're going to do is just practice a little bit here with our calculator. So let me kind of minimize this a little bit so I can pull up my calculator for us. So I'm literally typing those in just as they appear. Now I'm not going to type in every single one because I know that you are proficient with your calculator, but I am going to talk about letter D with you. So raised to the negative 5th. Got it. Hit enter. Maybe hit enter. There we go. All right, and of course we are rounding it to 3 decimal places, so I'm going to put 747.258. Okay, B, of course, same thing. Literally type that in your calculator exactly as it appears. You're going to get a very large number. Because remember, these exponents grow quickly. Here's my decimal point. 8 to the 2 pi. Let's punch this one in really fast. Again, straight as they appear, raised to the, and I'm going to actually use the pi key. I'm not going to round it off to 3.14 because I want it as accurate as possible. So I'm going to jot that down. And last but not least, let's do D in our calculator, because you might have forgotten where that Euler letter E is located. It's above ln, so I'm going to hit second ln, and then we are raising that to the negative 3 divided by 4. Enter. All right, let's round that to 3.472. Obviously, nice and easy, no work to show. Just type those in the calculator. Be conscientious of your rounding. All right, some graphs. It says graph by hand, identify asymptotes and intercepts where it hits the axes, of course, and determine whether the graph is increasing or decreasing. Always analyze the graphs, of course, left to right. Now, to graph it, because we can graph anything by hand, I'm just going to make a t-chart. I am going to be a little conscientious of what numbers I select for x, just because this function is going to go quickly. I'm going to start with something nice and easy. 3 to the 0 power. Anything to the 0 power is 1. Let's plot that. And I'm going to do 1, 3 to the 1st, 3, so 1, 3. Let's do 2. I can fit that on there, I think. 3 squared, 9. Now, I'm not going to put 3 because 3 cubed takes me to 27. Clearly going to be off the graph. So let's try some negative numbers. So 3 to the negative 1st. Now, like the warm-up problems, we don't want to leave our answers with the negative exponents. Technically, we are in the numerator, so I'm going to put that in the denominator. So I'm really 1/3. So estimate it on your graph best you can, negative 1/3. That looks about right. Then I'm going to do negative 2. Same thing, that's going to move into your denominator. So you really have 1/9. I mean, we're splitting hairs here. It's getting pretty small. Your next one will be 27. I'm not even going to try. You guys have seen my artistic skills, or lack thereof, but we're going to keep getting smaller and smaller fractions and keep getting closer to 0. So we got our graph, determining the asymptotes and intercepts, and determine whether it's increasing or decreasing. Okay, let's talk asymptotes. Asymptotes are the lines you get really close to, but you never actually touch or cross. That was our x-axis. We're going to get smaller fractions, but we never actually hit our x-axis or hit 0. So I'm going to put my asymptote down as y equals 0, horizontal line. So horizontal asymptote. Intercepts, it does touch your y-axis. Here is 0, 1, so I'm going to list that. And increasing or decreasing, this is a flashback to the first chapter. We're going to analyze our graph left to right. As I start out here to the left and follow to the right, I see it is rising, so it is increasing. Always analyze the graph left to right. Got it. Let's take a look at a couple other graphs here today. So f of 1/3 x, same thing. I'm going to make a t-chart. Plug some numbers in. I always like to start with 0 just because it's easy. So anything, of course, to the 0 power turns out to be 1. And I'm going to put 1 in. 1/3 to the first is just 1/3. Again, estimate it best you can. If I put 2 in, 1/3 to the second, you would square the top and bottom, and we end up with 1/9. Oh boy. So you can probably guess we're getting smaller and smaller fractions. I'm going to stop right there because I won't be able to really get anything more accurate. Let's try some negative numbers. So 1/3 to the negative first. Again, we can't have that negative exponent. So if I want to change the exponent to a positive one, we have to flip the fraction. So that, of course, calculates out just to be 3. Hey, that's not so bad. And then let's put -2 in. 1/3, can't write 1/3, there we go, to the negative second. I want to change it to a positive 2, so I'm going to flip the fraction, which lets me change that to 2. So we really have 3 squared, 9. 1, 2, 3, 4, 5, 6, 7. Got it. Okay, let's draw our curve. If I keep going, I'm clearly going to be off the graph. So same thing, we have our horizontal asymptote here at 0. We're going to get close to that x-axis, but we'll never actually cross it or touch it. We do have the same y-intercept. We're touching the y-axis right there at 0, 1. And then we're going to analyze our graph left to right. As I follow the graph left to right, I see this time we're falling, so this one is decreasing. And on to the next. Y, I'm like f of x. Instead of y equals 3 to the negative x, I'm going to rewrite that. Plus 2. Same thing, I'm going to make my t-chart. I always start with 0. Seems like plugging in 0 is the easiest to kick it off with. Because -0, I'm just going to put 0. So I'm going to have 3 to the 0, which is 1. 1 plus 2, 3. So now you can see we're moving our y-intercept up 2. I'm going to put 1 in. 3 to the -1. So we just calculated 3 to the -1 in the previous problem. That turned into a fraction. That was 1/3. So 1/3 plus 2. So 1, 2, and a third. Not there. Okay, let's try 2. 3 to the -2. Now same thing. We put in 3 to the -2 in a previous problem. That made it 1/9 plus 2. 2 and a 9. Estimate it. So I'm going to stop right there because I think we're going to just keep getting smaller and smaller fractions to go with our 2. Let's try a negative number though. So 3 to the -1. It's going to be a plus, of course. So I'm going to have 3 to the first 3 plus 2. 1. And let's try one more negative number, and that should be plenty to see our curve. So 3 to the -2. So I'm going to have 9 plus 2. Oh, off the graph. I'm just going to estimate it 1 off. Close enough. Let's get it drawn. Now this time, and you probably could pick this out from your equation, your horizontal asymptote moved up to 2. Of course, we're adding 2. Remember, that is a vertical shift on your graph. So I'm not at all surprised that that's a 2. My y-intercept this time is up there at 3, so 0, 3 I'm going to list for that. As we look at our graph as it falls left to right, it is falling, so decreasing. So again, just plot enough points so you can see the graph grid. It's not, you have to have 6 points in your T-chart or anything like that. Sometimes it gets off your grid quickly. Now this is one that the directions in your homework would definitely tell you to use your graphing calculator on. We kind of have to use our graphing calculator for that E value. So I'm just going to type it in just to show you here. I'm going to type it in right as it appears. So 2, remember E is second ln, e to the x minus 3. And let's hit graph. If your window is ever off, don't forget you can hit zoom 6, puts you back on the standard window. So let's look at the table. I'm afraid, oh yes, we have a whole lot of decimals here. I'm going to plot 3, 2, of course, that's one nice thing. 3, 2. Let's see what else we have in the table. I'm going to do 4, 5.4. 3, 4, 5. I'm going to just estimate it. Let's get another point on here. All those little small decimals, that's going to be rough. 2.7. Let's see what else we got. -3 gets you very close to the x-axis. That's going to be enough. I'm just going to use that and draw my curve. All right, same thing. We have to answer our asymptote, y-intercept, all of that good stuff. So let's start horizontal asymptote. Again, on this one's our x-axis. There's no vertical shift moving up and down, so not at all surprised of that. Okay, let's do our increasing, decreasing. As we follow the graph left to right, it is rising, so increasing. And then we need our y-intercept. It does touch the y-axis. I'm going to have to get that off my calculator because clearly it's a decimal. Remember when you are on the y-axis, x is 0. So let's pull the table back up. Let's take a look here. When y is 0, I'm going to round that to that 0.0996. Let's just round it to 0.1. Close enough. So of course with the e in it, we had to use our calculator. I couldn't calculate that one by hand. I know you're probably very sad about that. All right, let's get into some real world problems here. A couple formulas. You won't have to have them memorized, but you're going to have to know what some of these letters in the formula stand for. T, of course, time. Everybody knows T is time. Nobody ever gets that wrong. The balance A, an account with principal. So let's talk about what these principal, the P, represent. Principal, of course, is the amount of money you start your account with. So I'm going to put that as your initial investment. So if you go and open a savings account for $500, P is 500. Rate is the percent that the bank is going to make or give you for the interest. So that's always the percent. N is the number of times they compound the interest a year. So if they compound it, let's say 5 times a year, N would be 5. So I'm going to put number of compounds per year. All right. And of course, in our continuous compounding, they're constantly figuring out your interest. E is that second ln on your calculator. R, of course, is still rate, T, time. So we just have to read closely and just determine which formula we're actually using here. So example 3, $9,000, your principal, is invested at 8.5%, compounded annually. So not continuous, annually. So right away I know which formula I'm using. I'm going to jot that down, then we'll keep reading. So as I'm reading it, let's try to fill in some of this. So I'm going to back up. 9,000 we said was the principal, how much you're putting in. 8.5%, that's going to be our rate, but I'm going to put it as a decimal because I don't have a percent key in my calculator. Decimal goes 2 to the left. Now, compounded annually, that would be 1 time a year, still 1 for the N. Find the balance after 3 years. So our T is 3. So you are literally typing this in your calculator to figure out your balance. So let's pull up the calculator so I can show you that. So I'm going to type it in. Let's get out of the T-chart here. 9,000, parenthesis, 1 plus. Now I'm not going to put the over 1 because clearly not necessary. It's not going to change our value. And 1 times 3, we can do that in our head. Let's raise it to the third. So $11,495.60. Since we're doing a money problem, I'm going to round to 2 decimal places. Not too shabby. So your $9,000 turned into $11,495. I wish I knew a bank that paid 8.5% interest. That never happens, my friends. Okay, next up, 12,000 is invested at 9% annually. Find the balance after 5 years. So let's label some of these. T, of course, is our 5, 9% our rate, 12,000 the principal. Compounded quarterly, so that would be 4 times a year. And then compounded continuously. We're going to use that second formula on the sheet. So let's figure out our balance here first. So 12,000. 0.09 for the rate, this time 4 times a year, and we're doing it for a total of 5 years. Of course, I'm going to, when I put that in my calculator, do it as 20 years. You can too. Now, continuous, we're going to use that second formula, PERT, kind of the common little nickname there. Principal, of course, still the 12,000. Our rate is the 9%, and our time is 5 years. All right, so I just showed you how to type in something like this previous one. You should end up with an answer of $18,726.11. Again, pretty good return there on your investment. Let me show you how to type this one in really quick. 12,000. Remember that is second ln, and then I'm going to raise that just as it says, 0.09 times 5. So $18,819.75. We get a little bit better rate of return here, money-wise, on our compounded continuous. So like I said, you won't have to have the formulas memorized. They'll be provided to you, but just make sure you know what the different variables stand for in them. All right, next up. Last word problem of the day. Actually, these aren't bad for word problems. Why is the mass of a radioactive element whose half-life is 25 years? After 2 years, the mass in grams is given by, and of course there's that formula. Now, what's the initial mass? So initial, when you're starting, your time is at 0. The clock starts at 0. So I'm going to replace, of course, the T with 0. Now, you are welcome to type that right into your calculator, although we should be able to kind of do a little mental math here. 0 over 25 is 0. Anything to the 0 power, 1/2 to the 0 power is 1. 1 times 10, 10. We are in grams. You would get that same answer if you punched that in your calculator. How much of the element is left after 80 years? Okay, this one I've got to use the calculator for. So 10 times half. Same formula, but we're replacing T with 80. So let's pull up the calculator, punch that guy in, see what we get here. So 10. Now for the half, you can put 1 divided by 2. I'm just going to use 0.5, just a little easier for me to type in here. And then 80 divided by 25. All right, let's round that. I'm going to round that to 1.09. Let's go with that. And let's label grams. So, little graphing today. Be good with your calculators, of course. Watch your rounding. Enjoy your homework. Have a great day.